Good day, viewers. In this section, we are going to look at electric cell. The origin of current electricity begins with the work of Professor Galvani, a professor of anatomy, who reported that during his experiments with the leg of frogs, he noted that when he touched the leg of frog with items with the material copper and two different material, copper and iron, he noted that the leg of the frog twitched. That means it acted like the leg was shocked by electricity. He made several attempts and he concluded that definitely a sort of electricity exists in the leg of frog, and therefore he reported his finding, all his experiment in his book, and he called the kind of electricity in the leg of the frog as animal electricity. Okay, when he reported this work, another contemporary of his, Volta, was not happy with this conclusion. He looked at one side of his conclusion that he has two things here. He has by the right hand side he has the frog leg. In the left hand side he has some material, and Galvani just take this as his conclusion that the electricity is due to the from the leg of the frog. And Volta thought that this may not be the correct thing. The electricity should have been from the copper and iron. He therefore conducted several experiments where he removed the leg of the frog, and he concluded he replaced it with solutions of salt and some acid, and after 20 years he was able to prove that yes, the electricity can come from the metals and any ionic solution. So his discovery enabled him to construct the first battery. This is the first battery that existed, where we can have supply of current, a continuous supply of current. So let's see this is the construction of this battery in a sort of a simulated form. Replace the leg of frog with the following material. He brought zinc and copper, where the Professor Galvani used copper and iron. He put copper and zinc. And this side where the leg of the frog is, he brought some solutions. He brought some solutions of chemical solution of maybe salt. Explain that when you bring a metal, zinc, like zinc, and another metal, copper, and you separate them by a solution, an ionic solution, then in the solution, zinc will lose electrons through oxidation. Zinc will be losing electrons through oxidation, and the electron it lost if you connect wires from the zinc terminal to the other terminal, the copper terminal, the electrons will flow through the wire, and they will come and enter into the solution again. Okay, so this motion of the current or the charge carriers, the electron, through when you put a bulb along the fuse, the bulb can glow because there is provision of flow of current, some energy here, and this energy is due to the motion of the charge carrier that is coming through the wire to the solution. So this is the origin of the current electricity. The previous demonstration or the simulation show that this arrangement can produce a continuous flow of charge from zinc side to the copper side, through the copper side back into the solution, separating the two conductors. So this is the first battery, which is reported in 1800. So the constituent of this battery are such that this it is called electric cell, and the constituent are such that we have two different conductors, which are called electrodes, and these our two conductors are our zinc and our copper, and plus an acidic or ionic solution. These three things constitute the electric cell, and when we have two or more electric cells put together, they will give us current. So based on this, it's good we look at some situation where we can satisfy this condition and see whether we can see electricity. Okay. Here we have two setups that satisfy our three conditions. That we have two conditions, two conductors separated, or yes, with our solution of acid or solution of iron. Let's see if we have a lemon here, which we know is acidic, and we have a zinc nail here and a copper material here, copper nail or any copper material here, to see whether we can see this will act as an electric cell and produce light to produce electricity to light our LED here. This is one setup. Another setup is to use a fatato, common fatato, with some coil here, which is copper wire, and our nail here, which behave like our zinc, and also try to see whether we can get electricity from these two electric cells connected. Here is a demonstration of producing electricity from fatato, I mean from the lemon. Okay, we have seen that we can develop electric cell from lemon, and in class we have demonstrated that the potato also produce such electric cycles. So the zinc and copper are not the only material that can give us light. Can give us electricity. The rule is here that if you have different combination of electrodes, you have different material from zinc and copper, you can have different potentials. Different material may have different value of the potential. For instance, zinc and copper can give you a maximum of 1.1 volt in one cell, while aluminum and carbon, as our carbon to replace copper, our aluminum to replace our zinc, you can be able to develop up to 2.44 volt from the combination. Okay, so this is our electric. Okay, here is some circuit of the same we have tried. This kind of experiment can also be carried out at home. If you have the zinc material here, and you have the copper material here, and you have some acid here, we have a sulfuric acid as our dilute, as our electrolyte, then this kind of arrangement can, when you put a meter here, you can be able to record current. Okay, this is with a liquid liquid electrolyte. But in our today's battery, we don't use this liquid now. This is a version of our dry cell. Actually, it's not dry. There is some moisture inside it. So see our structure here. Our two conductors are our carbon and zinc. You can see zinc here. These are our two conductors. The zinc is the case now. So this is the negative terminal of your battery, and this is a positive terminal because this is replacing the copper. And we put there is some manganese oxide here. This material is put to overcome some problems of polarization that normally disturbs the carbon. Then the ammonium chloride here, this is our solution, but this solution is a form of paste. It's not liquid, but it's a form of paste here, and this is our electrolyte. So this is the nature of our current dry cell that we have of different category, AA, AC, AB, and so on. Okay, so this one satisfies our condition, and therefore we can get electricity from, we have been getting electricity from our dry cell.